In the history of astronomy, we have only ever confirmed 3 objects visiting us from outside our solar system. First came Oumuamua, then Borisov, and finally an interstellar comet known as 3I Atlas. The official timeline began on July 1st, 2025, when the Atlas Survey, a network of robotic telescopes, identified the object and secured its place in the astronomical record. But those records nearly told a different story. Humanity was 10 days and a few lines of computer code away from naming this visitor 3I Rubin. This near miss highlights a shift in modern science. Our ability to map the universe is no longer limited by the physical reach of our telescopes, but by the speed at which we can process the data they collect. In June 2025, the Vera C. Rubin Observatory was perched on a mountain ridge in Chile, undergoing its final preparations to scan the sky. It was during this period, exactly 10 days before Atlas sounded the alarm, that the Rubin Observatory captured the comet dead center in its practice images. The hardware performed flawlessly, documenting a visitor from another star system with clinical precision. Yet the discovery went entirely unnoticed at the time. It raises a difficult question for the future of astronomy. How does a multi-billion-dollar observatory look directly at a monumental discovery and remain completely blind to it? The answer lies in what the observatory was doing that June. The facility was in its science validation phase, a period of calibration meant to ensure the mirrors and sensors were functioning. Capturing light is the first step. To find a comet, you need a pipeline, automated software designed to sift through pixels and flag moving objects for review. During validation, the telescope captured data perfectly, but the pipeline wasn't active. The information simply pooled in the system, completely unanalyzed and unread. It took a team led by astronomer Colin Orion Chandler to find the missing link. They developed a custom retroactive pipeline specifically to dig through those early practice frames. Their digital excavation revealed the truth. The comet had been sitting in the data since June 20th, Rubin's very first night of practice imaging. In modern astrophysics, raw visual data without an active processing system is effectively invisible. Observation is now a partnership between the lens and the algorithm. These archived images provide scientists a critical look at the comet's behavior during its initial approach. By extending the timeline backward, researchers can track the early formation of the coma, the cloud of gas and dust that erupts as the comet's surface reacts to the heat of the sun. This ground-based data was eventually paired with observations from deep space. The JUICE mission and the Europa Clipper spacecraft were both on their way to Jupiter, carrying instruments capable of seeing the comet in ultraviolet light. By combining ground archives with spacecraft data, scientists mapped the ratio of water to carbon. This chart illustrates a composition differing significantly from comets native to our solar system. The nucleus is rich in carbon, traveling at 140,000 miles per hour. Based on this speed and trajectory, researchers estimate the object could be 12 billion years old, nearly as old as the universe. A few extra days of archived images allowed us to piece together the life story of an alien object from a system that may no longer exist. Despite the earlier images, the name 3I Rubin remains a hypothetical. The rules of astronomical discovery are rigid. Official credit is reserved for the first team to identify and report an object to the scientific community, not simply the first to have it appear in a file. Because Atlas had an active reporting pipeline and Rubin did not, 3I Atlas is the name that will endure. In the modern era, a discovery isn't made when the light hits the mirror. It's made when the system finally recognizes what it's looking at. As the Rubin Observatory enters full operation, it is expected to find up to 10,000 new comets over the next decade. We are entering a period where automated sifting will be the primary engine of discovery, scanning the sky with a speed no human eye could match. The story of 3I Atlas serves as a reminder of the opportunities hidden within our existing server banks. Our next major discovery may not come from a new observation of the stars, but from looking back into a hard drive to find what we have already seen.